Good afternoon. Question 3B from the 2025 GCE paper. It reads, a box contains 6 white circuit breakers and 4 black circuit breakers, all identical in appearance. A circuit breaker is selected at random from the box and not replaced. A second circuit breaker is then selected. Find the probability that both circuit breakers selected are white. So we can answer this one, I think, with the help of a tree diagram. So we are going to say, if we do this, let's say for white we represent it by W, and then for black it be represented by B, like that. So the number of elements in the sample space, we have 6 plus 4, which gives us 10. So in all, there are 10 circuit breakers. And then out of the 10 circuit breakers, we have 6 that are white. So the probability that the first one is white, or the chance that you pick a white one, there are 6 out of the 10 that are there. So that's the probability. And if this does not happen, the probability that what is picked at first is a black one, we'll say it is 4 out of 10. Then a second one was picked, and then we've been told the first one was not replaced, meaning the total is affected. So for the second time, for the second one to be picked, if the first was white, there's also a chance that even the second one can be white. So if the first one to be picked was white, it means we are now remaining with 5 white circuit breakers. So the probability will simply be 5 out of 10. If this does not happen, what can happen is the first one can be white, then the second one can be black. So the white ones, we have 5 that are remaining, meaning the total is now 9. In fact, even here, the total is 9. Out of that total of 9, the probability of picking a black one, because this time around we are saying no black one was picked. So all the black ones, the 4 of them are there out of the total of 9. If that does not happen, what can happen is the first one can be black, and if the first one is black, it means there will now be 3 black ones, and all in all there will be 9 circuit breakers. Out of the 9, the probability that you are going to pick a white one, then we'll be saying all the white ones, which is 6, they are there, because the first one to be picked is black. So we'll say 6 out of 9, that is the probability. And then if we pick the first one as black, the probability that the second one will also be black will now be 3 out of 9. So using this tree diagram, we can answer those 2 questions. So the first one, probability that both are white, meaning white followed by white, it will simply be 6 over 10, that's the first one being white, by 5 over 9. So if we simplify this one, 5 there is 1, 5 there is 2, then 2 there, 1, 2 there, it's 3, 3 there, 1, 3 there, 3. We could just have 3 remaining there, 1 on top over 3. So this is the chance that both circuit breakers are white. And then the second part, the probability that both circuit breakers selected are of different colors. Different colors meaning one is white, one is black. So probability, different colors. Now, it's possible that the first one can be white and then the second one will be black. So probability, white followed by black. It's also possible that the first one can be black followed by white. So probability black white. Now you can see that these two are mutually exclusive. So it's either the first is white followed by black, or, and where we are using that word or, that's where the plus is coming in. The first one black, the second one white. So from there we just say the first one white is 6 over 10, and second black, this is the one 4 over 9, plus the first one being black would be 4 over 10, and the second one being white would be 6 over 9. So we can simplify. Let's say 3 there, 2, 3 there is 3, and then we can say 2 there, 1, 2 there, 5. So on top we have 4, down we have 15, plus, even here if we simplify we still get the same. So since the denominator is the same, we just add the numerator and it gives us 8 out of 15. I think this is simplified. So that is our answer. Thank you for watching, and remember to subscribe, like and share. Thank you.